Hello everyone and welcome to another episode of Life Lessons with Hotard Algebra 2 Style. Today, dear people, we will be studying linear and quadratic regression. You will need your graphing calculator for this lesson. It does not have to be as big as this, okay, but you do need it to work. So go ahead and pull it out and turn it off. The objective of this lesson today is to use your graphing calculator to model real-world data, such as this one down here, in a linear or quadratic equation, and then use that model to make predictions about the future, about data that we don't already have. This is a branch of math called statistics. It's one of the most important reasons we study algebra is to use these functions we've been learning about to make predictions about the real world. Now, the good news about this lesson is every button you have to push, everything you have to type is already written out for you up the top in the graphing calculator instructions. So let's use that now to answer this. If you look down at the bottom, a convenience store manager notices that sales of soft drinks are higher on hotter days. That makes sense. So he assembles the data in this table right here, the high temperature for the day and the number of cans of soft drinks he sold for that day. And then ultimately, what we're trying to find down here at the bottom, we want to use a model to predict the soft drink sales if the temperature outside is 95 degrees. So before we type anything in, just looking at our data and using, what most people will call common sense. If we're looking for 95 degrees, if we're looking for a higher temperature, what would we expect about the number of cans that we would be selling compared to these? It's probably going to be more, all right? The answer should be bigger than 780. Let's find out how much more. So this is where I'm going to need to follow these graphing calculator instructions. It's written for you, but I'm also going to do it with you on the screen. So if you turn your graphing calculator on, all right, it'll probably bring you to that screen. First of all, I want to go to y equals up at the top left-hand corner. All right, and then you want to clear out any equations in there. So if you have anything typed in there, clear it out. Also make sure you scroll down all the way to the bottom. Make sure there's nothing typed in that bottom one also. Clear that out. And then also one other thing, you notice it says plot 1, plot 2, plot 3. I want all of these to be turned off. If any of them are highlighted, like here I have this one highlighted, scroll all the way up to the top, scroll over to whichever one's highlighted, hit enter. All right, and then that'll just unhighlight it. That turns it all off. All right, if any of those are turned on, it's going to mess up our graphs later. Now, I also need to clear out any lists in my calculator. So we're on step 2 now. I'm going to hit second plus sign for enter. So if you hit second button right underneath y equals, the plus sign, you notice right above it, mine's blue, yours might be yellow, but it says MEM. That stands for memory. All right, and then I want to clear out all the lists. So you can either hit the number 4 or you can scroll down to 4 and hit enter, and then hit enter one more time. That just clears out any data from any previous problems you may have done. Now, I'm ready to put this data into my calculator. So we're right here in the instructions to enter data. This is statistics, so I'm going to find the button that says stat. All right, it's right here next to the arrows, STAT. Push that button. I'm already on edit, so I can just hit enter, and then it brings you to this screen. Now, really quick, make sure your calculator says L1 here and L2. If your calculator says L1 and L2, great, just sit here for a second. But if it does not have an L1 or an L2, there's a quick fix for that. You need to hit the stat button again, and then the 5th one, setup editor, and hit enter again. And then you can go back to stat, enter. Now it should have the L1, L2. Now we're ready to type this data in. So all these numbers, we're going to type these numbers in L1, you just type it in, hit enter, and then these numbers in L2. So let's just do that very quickly. 55, enter. You have to hit enter after every number. And then scroll over to L2, type in the second list. Now it's really important that you're typing all of this correctly. For one thing, your list should be the same length. If one of your lists is longer than the other, it means you left out a number somewhere. So if there's anything you messed up on, you don't have to redo everything. Just go over to whichever one you messed up on, type over it, hit enter, it'll type that in for you. So once you've made sure you've got this data correctly typed in, it's in your calculator, now I'm right here. I'm ready to see the graph, to see the scatter plot. So we're gonna hit, we need to turn the plot on. We're gonna hit second, y equals, so second button, y equals, brings me to this screen. Right now my plot is turned off. I want to turn it on, so I'm going to hit enter. I'm going to hit enter on the word on to turn it on. And also just make sure that your calculator is listing L1 and L2 here. All right, it probably is. If it is not, then you need to make it do that. So I would go down, like if it did not say L1 here, I would go down here and I hit second 1. See how it says L1 above it? And that should make L1 appear on your screen. So turn that plot on, make sure it says L1, L2. Now I'm ready to see the graph. So I'm right here in the directions. I'm going to hit the zoom button, then 9. Zoom is up at the top middle, and then 9. I'm doing zoom stat. Should bring you to this screen. Now, one other thing, if at this point, if you have a dot that's a little bit off, if your graph doesn't look like mine, chances are you did not type one of these numbers correctly. So to fix that, just go back to stat, enter, and then fix whatever number looks off, and then go back to zoom 9, get your graph. It should match mine. Also, if you hit zoom 9 and you can't see a graph at all, chances are you have an ACT program on your calculator you did not exit out of correctly. So you would need to go to program, go to the ACT program, follow the instructions to actually exit it, and then hit zoom 9 again to get back to this graph. Now, that being said, looking at this data, does it look linear? Well, it doesn't follow a perfectly straight line, but does it look like overall this data is following a general linear pattern? Yes, it is. So it is linear data. Almost never in real life is data going to make a perfect straight line, but it will sort of follow that linear pattern. So we could say, yes, it is linear, so I'm ready to get my linear equation from this calculator. So I'm right here. To get the equation, right here, I'm going to hit my stat button, statistics, and then I need to calculate. Don't hit enter yet. Use your right arrow, scroll over to calculate. We want a linear model. We want linear regression. So which one do you think I'm going to use? The fourth one. You can either hit the number 4 or you can go down to number 4 and hit enter. If you have an older calculator, it'll automatically give you the answer. The newer calculator brings you to this screen. You have to go down, make sure it says L1 and L2 again, and then go down to where it says calculate and hit enter. That is my equation. Now what does that mean? This is y equals really mx plus b. It's ax plus b, and it tells you the numbers a and b. That's my slope and my y-intercept. So for this data, my equation would be y equals, and then I'm just going to round these off. So that's about 16.42. So y equals 16.42x, and then the y-intercept's negative, so minus 621.83. I'm just going to use 2 decimal places. It doesn't say where to round. That would be my model, my equation to represent this data. Now, I want to use that model to predict soft drink sales if the temperature is 95 degrees. I don't need to go through and type a whole bunch of other stuff in my calculator now. How do you think I could use this equation to make this prediction? I can plug in 95 in where? In for x. So I'm just going to, and I could do this on any calculator. I don't even need a graphing calculator for this last part. I'm going to type in 16.42 times 95 and then subtract 621.83. Let's see what that gives me. So I'm just going to clear my screen, go back to a normal screen and type that in. 16.42 times 95 minus 621.83. So I'm getting that number. Now, what do you think that means for this situation? It means I can expect to sell about how many cans? 938. You're not going to sell 0.07 cans. So for this situation, I would expect to sell about 938 cans if the temperature is 95 degrees outside. For the next part of this activity, you are going to need your Springboard book. This is Springboard page 167. Page 167. All right, it says a model rocketry club placed an altimeter I think it's called, on one of its rockets. An altimeter measures the altitude or height of an object above the ground. The table shows the data the club members collected from the altimeter before it stopped transmitting a little over 9 seconds after launch. Okay, so what I want you to do right now, just look at these numbers, and I want you to answer questions 1 and 2, all right? Just make a prediction based on these numbers. Don't type anything in your calculator. Just think, all right, what if this pattern continues, around what height do you think that rocket's going to be at 12 seconds after it's launched? Just pick a number, write it down, and then after you've done that, plot these points here on the scatter plot for number 2. So like 0, 0, 1, 54. All right, just plot the points and then see if the prediction you made for number 1 kind of makes sense for that graph. So pause the video right now, do that. Okay, if you did it, which I hope you did, your graph should look something like this. All right, now, you could have chosen any number, but let me ask you this. Just looking at this graph, if this is the height of the rocket a few seconds after launch, all right, and I'm trying to figure out 12 seconds later, that 12, do you think it's probably going to be bigger than 363 or smaller than 363? Probably going to be smaller, all right, because it's looking like it's falling back to Earth. So now let's use the calculator to actually find out what the calculator says is the correct answer. So if you flip to the next page, page 168, don't worry about number 4, but I want you to answer questions 3 and 5. Number 3 is asking us to type that data into L1 and L2, do that linear regression, and write the equation here. Again, don't worry about number 4, and then use your equation, number 5, plug in that 12, find the height after it's launched, and see how that compares to the prediction you made. All right, so again, pause the video now, type this into L1, L2, follow the directions from your notes, and get that equation. Did you do it? I hope so. Now, something interesting happens here. When you type it in and you get your equation, all right, the calculator says for the linear equation that represents this is y equals 41.4x plus 71.4. It said round to the nearest tenth, so that's 1 decimal place. Again, don't worry about number 4. Now look what happens in number 5. When I plug in that 12 into that equation, I get about this, 568 meters. Now, does that make sense for this situation? All right, because this is saying at 12 seconds, it's way up here. All right, now that does not make sense for this problem. We said the graph should be going down. Why do you think the calculator is giving us such a wrong answer? Well, the calculator is doing exactly what we told it to do. We told the calculator do linear regression. The calculator found a line of best fit that goes through these points and then says if we continue following that line, when we get to x equals 12, it's way up here. But is this data linear? No, it is not. It's following a parabola, a U-shape. It is quadratic. So I'm going to have to change things up slightly with how I type this in the calculator. All right, so the way you type quadratic data in the calculator, it's almost the exact same thing. All right, your steps are almost completely the same, just a couple little things I want you to add in. All right, when you're looking at your scatter plot, zoom 9, you're not just checking whether it's linear, you're checking whether it's linear or quadratic. All right, if it's following a parabola, a U shape, that's a Q, quadratic. If it's following a parabola, it's going to be quadratic. And then when I'm doing stat, after I've put in all my data, for my last step, when I'm hitting stat and going over to calculate, if it's quadratic, I don't want to go to linear regression. Which one do you think I'm going to use? Quadratic regression, the 5th one. All right, so just add a little note in right here. 4 if it's linear, 5 if it's quadratic regression. And you do everything else the same. So I would go to the 5th one, hit enter, calculate, and then it would give me this. Now, y equals ax squared plus bx plus c. What form is that? Is that standard form or vertex form? That's standard form. And these are my numbers for a, b, and c. So I would plug those in. So my equation here, and this is the answer on page 169. This is the answer to problem number 7. All right, I would get y equals negative 6.9 x squared plus 103.8x minus 11.8. Make sure you're paying attention to negatives, okay? If it's a negative, you need a minus. That does matter. All right, that's my equation. And then skipping 8 and 9, if you go to question 10, if I plug in that 12 in for all the x's and work it out, I get about 240 meters. Now, does that make sense for this problem? Yes, it does. 240 meters, that would be around right in here, which would make sense, all right, if it's following that parabola. So, main thing to remember here with these regression problems, don't just mindlessly type numbers. You need to check when you're looking at the graph, check whether it's linear or quadratic or some other completely different function. All right, make sure you're using the correct one.